And thank you for attending. Thank you for being here. So today we're going to take a very quick look. We got about a half hour, plenty of material to cover. New features in SQL Server 2014. By way of a quick introduction, my name is Don. I'm only Donald when I'm in trouble. I'm an MCT, a Microsoft Certified Trainer with New Horizons. I've been here for about 14 years. And my key focus is SQL Server. So when a new version comes out, it's a very exciting time. So what we're going to cover today, talk just a little bit, we got to have a little bit of marketing here. So we're going to talk a little bit about New Horizons and our training offerings. And then I'm going to give a talk about just a couple of the new features in SQL 2014, a couple of the most exciting ones. Do a quick demo, highlighting one of the most important features. And then, time permitting, we'll turn it over to your questions, which try to make them easy ones so I can easily answer them. But we'll get to your questions. All right, so real quickly, New Horizons, we're a big training company. I think, I could be wrong, it happened once before, I think we're the biggest computer training in the world. So you can see the numbers for yourself. We got a lot of classrooms, a lot of instructors in a lot of countries. And the training, what I spend most of my time doing now is something called Online Live, which is sort of like this webinar, although it's a bit more sophisticated. It's the traditional Microsoft training with all of the same labs and all of the same everything, except it's delivered over the internet. So you don't have to get in your car and deal with traffic and weather and whatnot. You can sit in your pajamas and take a full-blown Microsoft official curriculum class or training in many other technologies. So it's a fantastic technology. Works really well. We do still have some instructor-led training. It's I think it's a little old-fashioned nowadays, but it's certainly there. And other customized training. All right, we've got a lot of partners. I pretty much live in the Microsoft world, but we do IBM training, we do Red Hat, we do Apple, we do Adobe, you name it. Pretty much if it's in the IT world, we do it. All right, so with all of that said, SQL 2014 has been in the works for a while. Now, it was a pretty quick release cycle. We just got done dealing with SQL 2012, and sure enough, exactly 1 month ago today, they released 2014 into production. Of course, a lot of companies have been using it for a while, so it's not exactly new. And I focus principally on OLTP, Online Transaction Processing Databases. It's the typical database that most of us are familiar with. So kind of managing your daily operations. The other side of the coin, if you will, if we're talking about SQL Server, there are two use cases. There's OLTP and then there's OLAP, or Online Analytical Processing. And that gets into business intelligence, data warehousing, decision support. All of these are similar terms and mean basically the same thing. Well, since the version 7 of the product, so we're going back to the late 90s, Microsoft has, of course, released many versions of the product since then, but the focus has tended to be towards business intelligence. So certainly every new version that comes out, whether we're talking about 7, 2000, 2005, 2008, 2008 R2, 2012, 2014, they all have new features, for every different audience. This is the first version that I can think of that really focuses mostly on performance in the OLTP world. Now, certainly there's some new features around business intelligence that are very important, but the main feature that I'm going to focus on is called Hackathon, or at least it used to be called Hackathon, and that is very exciting for OLTP, for your traditional online transactional databases. So, for example, the world that I live in is training. Our OLTP database deals with students and enrollments and courses and classes, etc. So performance is more and more important issue, more and more important as time goes on, because we're dealing with larger and larger volumes of data. So that's one of the key features. So we're going to go through a few of them, but that's what I'm going to focus on here. Specifically subtitled, What the Heck is Hackathon? And you're not going to believe this, but I originally didn't intend that to be a pun. I realized after I wrote it that, hey, heck and hackathon, that's funny. All right, so what is it? Hackathon is Greek for 100 or 100-fold. So Microsoft loves code words, And this technology, this in-memory technology that I'm going to be discussing, and you'll notice the PowerPoint's rather sparse. I'm not a PowerPoint guy. Its aim is to increase performance many times. Now, is it a 100-fold increase? No, that's a goal. But it's a major increase in performance. All right, so what is it? Well, we need to talk about traditional databases for a minute. When SQL Server was created, and this is true of most products like Oracle and DB2 and other database systems, disk space was, while not cheap, certainly cheaper than memory. Memory was considered a very, very expensive resource. So the focus has always been storing data on disk. And to get performance, we'd have to do things like get faster CPUs, and if we can, more memory. Well, as time has gone on, we're now in the year 2014, CPUs aren't getting any faster. Moore's Law expired a while ago, so we're pretty much stuck at the same speed. Now the idea is let's have more processors, let's have more cores. Disks have gotten faster, but only to a point. If you're talking about a traditional hard disk where we store our data, we pretty much capped out at 15,000 RPMs, which sounds like a lot, but compared to memory and CPU speeds, it's incredibly slow. So the disk has become a major bottleneck. So how do we compensate? Well, processors aren't getting any faster. We can add more of them. There are techniques for getting more performance out of our disks. We have solid-state drives. That certainly helps. But really, memory becomes the big issue. Memory prices are falling faster and faster. We have more and more memory available. So your organization, if it has the need and the resources, could buy a server with a terabyte of RAM and 16 cores of CPU for less than $50,000. Which, for a large corporation obviously isn't a whole lot of an investment compared to what we used to do with mainframes and whatnot. Now, so the idea is let's put as much of our data in memory as possible. Now, hasn't SQL Server done that for years? Yes. You have something called a buffer pool, and as data is accessed off disk, it's read into the buffer, into memory, and as long as it keeps getting reused, it stays there. And this has been available for as long as I can remember with SQL Server. So my recommendation has always been to my customers, my students, my clients, have as much RAM as you can in the system, ideally enough to cache the entire database, and a lot of your worries as far as from a performance standpoint go away. Well, that's not entirely true. It's still great. I mean, if I can have my data on solid-state drives, they're a lot faster than traditional disks. If I can put as much data in memory as possible, it's still a lot faster. But you're still, in SQL 2012 and prior versions, reliant upon the traditional database engine in SQL Server. So from that perspective, it really doesn't matter where your data is, whether it's in memory or disk. I mean, yes, memory is a lot faster, but you're still dealing with contention. You're still dealing with locking. Locking is the mechanism that supports concurrency, multiple users accessing the same data at the same time. So back in SQL 6.5, back in the mid-90s, we had something called pin tables, where you could tell SQL Server to take the data in the table and pin it in memory and keep it there. And people tend to think that this new technology, codenamed Hekaton, I don't actually know what the technical term for it is now. I think it's called in-memory tables or memory-optimized tables. People think it's the same thing. It's actually not at all. Because what Microsoft realized is we need an entirely different engine to support true in-memory data. So now in SQL Server 2014, we have two separate engines. We actually have three, but I'm not going to be concerned with a third one for right now. We have the traditional engine that deals with, well, data traditionally, and deals with locking and maintaining tables on disk and I/O out to disk and RAM. All of that stays pretty much the same. We have this new in-memory engine that works alongside it. So what we have to do to achieve this, and I'm going to demo this piece, is we create a database that is set up to support in-memory tables. Now, a lot of people, when they heard about this Hekaton Hackathon technology, when it was first announced a couple of years ago, they thought, okay, I can flick a switch and put my entire database in memory. And that's not how it works. And it's worth noting, and I'm going to go through this a little bit, there are some serious limitations to this right now. But for specific situations, particularly frequently modified tables that are subject to high contention, many users accessing them. So think about a high-capacity online order system. For something like that, in-memory tables are a godsend, although there are limitations. You know, we're still at the early stages of this technology. There's some things to be ironed out. But I don't have the numbers in front of me, unfortunately, but Microsoft has customers that have been using this for a while and have seen 7-, 8-fold performance increases by caching certain specific tables in memory. So for most tables, honestly, in your database, you're not going to necessarily see a huge benefit from this because we still have to do I/O out to disk, where there's still logging that goes on. There's still issues involved, and it doesn't matter necessarily whether the whole table's in RAM or not. But for tables that can benefit from this, especially, like I said, highly modified, highly contentious tables, the whole idea, the key to this is not just putting the data in memory, but not having locking. This is a lockless, latchless technology. That's the key to the whole thing. So in order to achieve that, they needed an entirely new engine that can deal with data modifications without requiring locks. And I'll talk more about that as I go through the demo. All right, so for OLTP workloads, concurrent queries, large data modifications within transactions, that's definitely, that type of data would be a candidate for this. And there's another issue with tables where you're doing frequent inserts. What I've always taught my students and what I've always done for my customers is create tables with identity columns or primary key values that increase sequentially and put a clustered index on that column. And if you're familiar with this, what the clustered index does is it physically stores the data on disk in a certain order. Well, that can optimize inserts, but in a highly contentious table, what you wind up with is what are called hot pages. Pages in memory that are frequently accessed by multiple connections, and that causes contention. So even with solid-state drives, even with pinned tables in memory, you're still going to run into this issue. So we need a way to turn off locks, and that's what this does. It still maintains concurrency. It's still, you can still persist the data so that it will survive system shutdowns, but it's done in an entirely new way, and that's Hackathon. All right, now, before I demo it, I just want to go through a couple of the limitations, which at first blush are serious limitations, but there are ways to work around them. So, for example, there are certain data types that won't work with this in-memory technology. Most of them are your traditional kind of blob types like image, text, XML won't work, hierarchy ID won't work, there's a few others. Now, the bigger issues. You can't do database mirroring on an in-memory table because the way the engine works, it just doesn't support it. Now, mirroring is deprecated, so that's actually not as huge an issue as you might think. Always on does work with this. Always on is since 2012, has been the new way we do mirroring. Now, computed columns won't work. As a developer, that to me is a big limitation, but it's just the way it is. The technology just doesn't support it. Even bigger, triggers don't work. Foreign keys don't work. Primary keys, you have to have a primary key. As a matter of fact, that's a difference between this and a traditional on-disk table. Technically, on-disk tables don't have to have primary keys, although they always should. In Hackathon, you have to have them, but you can't have foreign keys. Now, that's probably the single biggest limitation, quite honestly. There are ways around it that I'll talk about. Identity property won't work, so those auto-incrementing values for primary keys, you have to figure out another way to assign those key values. Clustered indexes aren't supported because clustered indexes are a physical storage technique. These tables aren't physically stored, they're in memory. So that's actually a non-issue. In a traditional on-disk table, you either have a clustered index or a heap structure. Well, in memory, it's a completely different structure. You can't do data compression isn't a big limitation because these tables are based, this whole idea is based on something called VertiPack, which was actually available back in 2012 for column store indexes. It's a highly compressed data format anyway. But the biggest limitation, as far as I can see, is with constraints. Foreign key, check, and unique constraints aren't supported. So typically the way to get around this, and keep in mind it's a brand new technology, so people are still working on ways around it, would be to create on-disk versions of the tables, work with them in memory, and then persist the data back to the on-disk versions, maybe as a batch or as a scheduled job or something like that. So yes, there are limitations. It's still a fantastic technology, as I'm going to hope to show you here. So without further ado, before I go to any other technologies, let me switch my screen here for just a second. It's going to take me 1 minute to get to this. And what I'm going to do is walk through a demo where we're going to create a database that has this capability of storing these memory optimized tables. Then I'm going to create a couple of tables, one that's memory optimized and one that's not. Now, because you've got both database engines running, the traditional database and the in-memory, they interop. So I can write a query that joins a table that's stored on disk to a table that's stored in memory, and there's no issue there. So let me bring up the demo just real quickly. Here it is. Hopefully everyone can see this on screen. It's just a virtual machine that I have running. This is running Windows 2012 and SQL Server 2014. And the first thing I'm going to do is create a database to host the data. So I'm going to right-click on the databases folder. You can see the Management Studio doesn't look terribly different from the previous versions. There's a few new bells and whistles. The database name I'm going to call something brilliant like memdemo. So this is just a plain old database at this point. I'm going to blow this up so you can see it better. Now, here's where the memory optimized piece comes in. I'm going to go to File Groups, and the first thing that I have to do, the File Groups tab is significantly different in 2014. We have our primary file group for our on-disk data, and of course I can create additional traditional file groups like I always could. I'm going to go down to the memory optimized data piece and add in a file group. Now this file group data is going to be stored out on disk in the file stream. File stream was something that was introduced back in 2008 for storing blob type data, images, text, things like that, sound clips, video clips, out in the file system. But transactional consistency is maintained within the database engine and the file store. So this is a similar idea. We're just using it for a different reason. Now, the tables in memory, why do I need this? Well, we need a way to persist the data across server restarts. So obviously, if it's written to, if a traditional table is written to disk, that's not an issue. That's what disks are for, is to persist across restarts, to be non-volatile. Well, if I have a table in memory and I shut down the server, I'm of course going to lose that table from memory. Now that, by the way, that might be fine. And I'll show you, or at least I'll talk about how you can create a table that isn't persisted across server restarts. But I want the capability of persisting those changes, so I'm going to create what amounts to a folder out on disk, and it's this memory optimized data file group that can keep track of changes, so when I restart the server, it brings those changes back. So it kind of reinflates the data, if you will. And that's in the form of what are called checkpoint files. Now, you're not going to be able to actually see those directly, but I'll at least show you what the folder looks like. So I'm going to add in this file group, and I'm going to call it memfg for memory file group. And notice it's in the file stream, although it doesn't have any files yet. We're going to get there. Hit Enter. Okay, that changed. That's just a metadata change. Now I'm going to go back to General. And I need to create a new file here that's going to store this information, this checkpoint information for these in-memory tables. Right now, if I wanted to create an in-memory table, I can't. I have an additional step. So what I'm going to do is go out to my disk. I have a solid-state drive here I'm going to create a folder on. And I'm just going to call it, what do we want to call this? Let's call it memdata. Just a plain old file out on the NTFS system. It happens to be on a solid state disk for performance, but other than that, it's just a plain old file or a plain old folder. So now I'm going to go in and add a new file, and I'm going to call it memdata. Call it anything you want, it doesn't matter. But here's the key part. Under file type, instead of traditional rows and data, I'm going to choose file stream. It knows immediately that I only have one file group enabled for file stream, so it picks MMFG. I didn't have to do that. And I'm going to go put it in that folder that I just created. So I'm going to browse out. I didn't even pay attention to what that warning was. I know it doesn't mean anything. And I'm going to find the folder out on my solid state disk. And again, this is going to store files that will represent the rows that I insert and that I modify. So it's all done in memory, but just like the checkpoint process writes changes from the dirty memory for a traditional table into the actual table structures, here we're going to write any changes to the in-memory data out to these checkpoint files. Now, why is there a difference? Again, it's to support lockless, latchless technology. We're not going to have locks. We're not going to have latches. So contention becomes a non-issue. Now, you're going to get a lot of row versions generated, but there's a lockless garbage collection that goes on that cleans all of those up. Hit OK. So there it is. Hit OK. Now I've got my database. And just to prove it, doesn't look any different than any other database, but there it is. Now, let's play with it. So I'm going to create an in-memory table called memory table, fantastic name. It's going to have an ID column, which is an integer. It can't be null. It's the primary key. You do have to have a primary key. You can't create clustered indexes, but the primary key has to be indexed. That's always been true. So indexes on in-memory data are quite a bit different than your traditional indexes. It's not a traditional B-tree structure. It's a hash table. It's in memory. And when you create one of these, you can now, because of the way these indexes work on an in-memory table, you can only have 8 of them on a table. You can have up to 999 indexes on a traditional disk-based table, although that's an insane number. You can only have 8 on an in-memory table. So there are some limitations here. And the maximum size of a table can only be 256 gig, which is a decent amount, but it will be a limit for obviously some customers. The bucket count is how many unique hash values, and the recommendation from Microsoft is that number should be roughly 1.5 unique values in the index. So what we're saying here is if we have 500,000 rows, we've got 1 million rows in our bucket to accommodate them, or 1 million hash values. All right, now, with memory optimized makes this a memory optimized table, so it will be 100% in memory. You specify a durability. Now the durability is, can it survive restarts? Schema and data means yes. So the data and the schema, the structure of the table, will persist across restarts because of that file stream folder that keeps track of all the changes. You do have another choice, schema only. So that would be faster because now we're not bothering to record the changes out to those checkpoint files, but it's not going to persist restarts. The obvious example for something like that would be session state within a web page within ASP.NET. So there are times when I just don't care about surviving restarts. I just want to dump the data into memory and keep it there. But in this case, we're going to persist it. So I'm going to highlight this code and run it. And drag this down so we can see it a little bit better. Now, we're going to create the same table, except this is just a traditional on-disk table. But the same columns, ID and date value. This one has a primary key with a non-clustered index. Could be clustered, but it's not. Now, here's where the rubber's going to hit the road. We're going to begin a transaction where we're going to insert 500,000 records into our on-disk table. So this is just, you could do this back in SQL Server 4.5 if you wanted to. This is very old. Let's run it. And we're going to watch the toilet bowl spin here and look at our count. And it's going to take anywhere from about 40 seconds to a minute to insert these 500 virtual machine in the world. So we're waiting, and we're waiting. All right, I lied to you. It was actually faster than I expected it to be, so it was 22 seconds. Probably because it's around lunchtime in the East and most people aren't doing the labs. All right, now, if I select from the table, I should have 500,000 records. Cool. Now, I'm going to do the same exact thing with the in-memory table. Now, when you execute transact SQL statements against in-memory data, it gets silently translated into a procedure, a compile procedure in C, the language C. So it is faster, but that compilation, that interpretation of the transact SQL still has to take place. But this should still be faster. I'll be disappointed if it's not, inserting 500,000 rows into the in-memory data. So we're trying to beat 22 seconds. It's usually about half. Don't make a lot. Okay, it was roughly half, 12 seconds. Now, multiply that over a huge table that's being hammered with transactions all day long. You can start to see some of the performance benefits. But wait, there's more. So let's make sure that we have 500,000 rows in that table. All right, so it is an apples-to-apples comparison. Now, we're going to delete that data. We're going to create a stored procedure. Now, when you have stored procedures that execute against in-memory data, they're compiled into native code. So, unlike interpreted transact SQL, now when you write a traditional stored procedure, it is compiled, but it still has to be interpreted at runtime. With a stored procedure against in-memory tables, it can be compiled into true machine code, and it's going to be a lot faster. There are a few things you got to do this. You have to say with native compilation. You have to turn on schema binding. That's not a new feature, but what it does is locks the definition of the stored procedure so that you can't modify the underlying table or tables without dropping this first. And you do have to have an execute as, which sets the security context. And in this case, we're just doing it as owner, which will be DBO. Now, this is other than that, this is the same exact code. We're going to insert 500,000 rows into the in-memory table. So I'm going to create the stored procedure. All right. Now, I'm going to execute it. It's going to run the same code. It's going to insert those 500,000 records that just took 12 seconds. Let me do it with stored procedure. Done. Didn't even count how much time it was. It was less than a second. So the combination of these in-memory tables and compiled native code stored procedures makes data modifications lightning fast. And I can't really show this here, you're not dealing with the contention issues because it's lockless. Although that was actually one of the benefits of the reasons the in-memory table was faster in the first example. So once again, if I look at the data, I've got 500,000 rows, and it took less than a second instead of 12 seconds. That's significant in a highly contentious environment. And I can look, there's a few new dynamic management views specifically for in-memory tables. They all begin with DMDB XTP. And this just shows me some statistics about how much memory is reserved. So 47 meg for this table, and I'm taking up almost all of it. And that grows dynamically as needed. All right, I've taken almost all of our time there, but that was just a quick look at what Hackathon's all about. It's the biggest new feature. So let me just real quickly, we're going to run just a little bit long, I think. So there's as a DBA, I'm very concerned with backups. There's nothing particularly fun or exciting about it, but it's a big part of your job. So in 2012, I want to say, what was it, Service Pack 2, they introduced the ability to back up to a URL. So what this allows you to do is back up directly to Azure storage in the cloud. You need to have off-site copies of your backups. If disaster strikes, I don't want to be relying on a single backup, and I don't want to be relying on a backup that's in the building that just burned down. I hate to put it that way, but we need off-site. Well, that's difficult to achieve, at least cheaply. So starting in one of the later service packs in 2012, they gave you the ability to back up directly to a URL in Azure from T-SQL, PowerShell, and SMO via PowerShell, Server Management Objects. Now in 2014, it's fully supported. You can do it directly from Management Studio. As well, you can encrypt your backups. Now, backup data is sensitive, obviously. It's a backup of your database. Previously, the only way to achieve an encrypted backup without using third-party software was to encrypt the entire database using TDS, Transparent Data Encryption, TDE, sorry. Well, now you can natively encrypt your backups using the algorithms you see here on the screen. There is overhead involved. You'll chew up some extra CPU, but your backups are encrypted and therefore safe. Always on enhancements within always on. That was the big new feature in 2012, at least as far as kind of, well, it doesn't matter what type of database it was, but as far as high availability, now you can create replicas, which are always on availability group replicas out in Azure. So again, it gives us more high availability. If I lose everything on premises, I now have an off-premises copy. And you can more secondary replicas. In always on in 2012, you can only have 4. Now it was like 8. Now it does depend, by the way, on what edition of SQL you're running. So for example, the Hekaton technology is only available in the Enterprise edition, Enterprise and Data Set and Parallel Data Warehouse. It's not available in Standard. One of the nice things they did do in Standard is, and this was a last-minute decision, in 2012, the most RAM you can address in the Standard edition is 64 gig. They bumped that up to 128 in 2014, which is very nice. All right, that was a lot in a very short period of time. It wasn't as much as I thought I'd get to, so I apologize. I had to kind of rush there. But, Anthony, if there's any questions, I'm here. And if not, I will wish you all a wonderful afternoon.
Yeah, so I know Dawn is teaching a class today, so if there's any questions, we'll be here for another 2 or 3 minutes, so feel free to type them in there and I'll relay them to him.
I did want to say that the 2014 SQL Server classes will be hitting our schedule in July. I know I'm already scheduled to teach one. So what you saw there was about a 10-minute slice out of what you'd see over a course of a 5-day class if you choose to come and attend one. I don't know specifically, but that demo I think would probably be part of what we would cover in the admin course. It's just something I kind of lifted out. And obviously, if you want more information about any courses, you can talk to your local New Horizons rep.